Good afternoon, and welcome to the Akron Roundtable. I am Michael Swartz, President of the Akron Roundtable Board of Directors. The Roundtable is brought to you over radio station WKSU 89.7 FM from the Quaker Station at the Quaker Inn on the campus of the University of Akron. The radio broadcast is underwritten by Cascade Audi. We would also like to recognize the Akron Beacon Journal and Ohio.com for being a legacy sponsor of the Akron Roundtable. Please mark your calendar now for our next Roundtable luncheon scheduled on Thursday, April 16th, 2015, when the Akron Roundtable will host a diverse group of panelists in a discussion which follows up on the Akron Beacon Journal series, Who Will Lead? The title of this panel is aptly named #AkronLeader, Building the Conversation. To make a reservation for any of the Akron Roundtable luncheons or to purchase a subscription to our luncheon series, please visit our website at akronroundtable.org. We also invite you to like us on Facebook. Today, the Akron Roundtable is pleased to host Dr. Mosley Thompson, Distinguished Professor in the Department of Geography and Director of the Bird Polar and Climate Research Center at The Ohio State University. She will be discussing global climate change, the evidence, challenges, and our options. I will now ask Frank Buckholzer, a member of the Akron Roundtable Board of Directors, to introduce our presenter.
I'd first just like to say, having these students here warms my heart. You are the future, and what we're going to be talking about today has a lot to do with the future. Thank you all so much for joining us today for what I think is going to be a very interesting presentation. Global climate change, the evidence, the challenges, and our options. And the topic could not be more timely, as the American Association for the Advancement of Science, the world's largest non-government general science membership organization, and the executive publisher of Science magazine, a leading scientific journal, has recently stated, and I quote, "There may be no more pressing issue today intersecting science and society than climate change." In addition, both the National Oceanic and Atmospheric Administration, NOAA, and the National Aeronautics and Space Administration, NASA, are at the forefront of the scientific investigation of the dynamics of the Earth's climate on a global scale. Recently, NASA observed, and I quote again, "The long-term warming trend and the ranking last year, 2014, as the warmest year on record reinforces the importance of NASA to study the Earth as a complete system, and in particular, to understand the role and impacts of human activity." Accordingly, through the recent 2014 National Climate Assessment, an authoritarian scientific review of climate change in the U.S., they say too, the impacts of climate change are already being felt throughout the country, including where we live in the Midwest. So now to our wonderful speaker. Dr. Ellen Mosley Thompson, a distinguished university professor in atmospheric science and director of the Bird, Polar, and Climate Research Center at Ohio State University, has led 9 expeditions to Antarctica and 6 to Greenland to retrieve ice cores. She then uses the chemical and physical properties preserved in these cores that were collected from the polar ice sheets and high mountain glaciers to reconstruct the Earth's complex climate history. These records indicate that the Earth's climate has moved outside the range of the natural variability that the planet has experienced in at least the last 2,000 years. In other words, it's man's impact on the planet that is now the primary driving force of climate change. Dr. Ellen Mosley Thompson has published 227 peer-reviewed papers and is the recipient of over 50 research grants. She's a member of the National Academy of Science, the American Academy of Arts and Science, and numerous other such organizations, in addition to receiving a number of awards and honors for academic, scientific, and governmental entities. As an aside, Ellen's husband, Dr. Lonnie Thompson, is also a world-renowned paleoclimatologist who has spent his professional career unlocking the secrets of climate in the world's highest mountains via his collection of ice cores. It's really fun. I found Ellen was going to be here with us today. I was able to be with us today. A couple of years ago, the mutual friend of ours, who was chief scientist for climate change at the Climate Institute in Washington, we had the pleasure of touring the Bird Polar and Climate Research Center in Ohio State with none other than Doctors Ellen and Lonnie Thompson as our guides. Not surprising, one of the highlights of our tour was seeing and walking through the huge cold storage facility, which ranges in temperature from below 25 to below 40 degrees zero, where Ellen and Lonnie keep all the ice cores they have collected from around the world. So you can see our chairman here, who is from First Energy, you're pretty important if you have connections in Columbus to keep that electricity going, because there are about 700 of them, each 3 feet to 4 inches in diameter, and quite literally, because the source of these specimens are rapidly disappearing from the planet as the glaciers and ice caps melt and disappear. These ice cores are a very unique, important, and irreplaceable collection of the planet's climate history. Our visit, needless to say, culminated with a delightful and fascinating dinner, with Ellen and Lonnie charming us with the science and, of course, the high adventure of Antarctica and the Andes in South America. So with no more ado, I would just love to invite to the podium explorer, adventurer, acclaimed scientist, and director of the Bird Polar and Climate Research Center, the wonderful Dr. Ellen Mosley Thompson, to come to the podium. Ellen.
I'm on the short side. Well, thank you very much. Thank you for the introductions, and I just wanted to say what a thrill it is to be here. Mike Sherman called me a few years ago, asked if I would be willing to come up, and unfortunately at that time my husband was in the throes of a heart transplant, and I said, no, I can't come right now, but call me again. And he called late last year, so I'm just absolutely thrilled to be here with you. And I wanted to thank Fran for the introduction, particularly talking about the ice cores that we have at Ohio State, and that Lonnie and I have devoted our entire career to collecting, because I'm really not going to talk about the ice cores today, but Fran did that for me. I'm really going to focus today on global climate change. But first, I'll draw your attention to the table over here on the right. There are some handouts that actually contain lots of information for you to use later if you want to continue to self-educate on global climate, on climate science. There's a lot of erroneous information out there, as you can imagine, but the information that I've provided comes from some of the societies that Fran mentioned, also from the Intergovernmental Panel on Climate Change, etc., and the peer-reviewed literature, which remains, of course, for the scientific community, the gold standard in terms of information. If you look up at the screen, you'll see 3 of the places where our team has drilled ice cores. The Bruce Plateau, which is the one that would be on your left, I drilled there in 2010. It's in the Antarctic Peninsula. And then on the right is a place in Greenland where we drilled in 2007. But I also wanted to highlight the photo in the middle, because this is the Desapu Glacier, which is in the southwestern part of the Himalaya. That site is 23,000 feet in elevation, and our team spent 50 days there. I was not there, Lonnie was there. Maybe that's contributed to the heart transplant, I don't know. But anyway, Lonnie and I essentially have divided up the world in that I work in the polar regions and he works pretty much in the high mountains. And so the work that we've done is a collective effort by not just Lonnie and Ellen, but by our research team. And I'm just showing you here, the scope of our team includes these. The names on the left are the research scientists. Then we have our postdoctoral researchers and our graduate students. And our research program is funded by both National Science Foundation, by NASA, NOAA, and we've had funding from the Gary Comer Foundation. So the way I'd like to structure the talk, because we are on air, and I was asked to keep the number of slides to a minimum, the way I plan to do this is to walk through these key points and say a little something about the key points that you see up here. And I'll read them, of course, for the people on the radio, as well as those in the back who may not be able to read that. And I'll come back to just a few of these key points and illuminate a little bit more about them by using just a very select number of slides. So, just starting down the list, Earth's climate is changing, the world is warming, and most importantly, the debate on that is over. There is absolutely within the climate science community no debate as to whether the Earth is warming. There are forces out there that try to give a picture that the scientific community is conflicted on this. But the Pew Center has done polls, and 97% of climate scientists agree with this statement. The second is, it's very important that we understand the difference between climate and weather. And I'm going to come back with a few slides that will help with that. But they are quite different beasts, so to speak. The other thing that's so important to recognize is that, as in your wonderful introduction, you talked about how short a time the humans have been on the planet. But Earth's climate has been changing over all of Earth history. And the drivers of climate change are both natural and they're anthropogenic, or that's a term for human produced. And only until the last, say, 150 to 200 years have humans really been in sufficient number and have our activities been so sophisticated that we have been able to have a very visible impact on the Earth's climate. So in terms of the natural drivers of climate change, or of the climate system on our planet, number one is the sun. The output of the sun changes over time. It changes on an 11-year cycle, and there are other longer-term cycles. Another important forcing mechanism that's natural is our volcanoes. And volcanoes, when sulfate aerosols are injected very high in the atmosphere, they cool the planet. And this is an important characteristic of sulfate aerosols. We saw in 1991, when Mount Pinatubo erupted, the globally average temperature on the planet essentially stagnated for 2 years. But that was a natural event, and it just demonstrated again that there's natural variability in the climate system as well. And the third factor are these internal systems, such as El Nino. You've heard a lot about El Nino. It brings different climate climate to, say, the southwestern U.S. and the southeastern U.S. But then we have the anthropogenic mechanisms that force climate, and those are the greenhouse gases, principally the most important one, which is water vapor, the second most important, which is carbon dioxide, and the third most important, which is methane. The latter two are, all three are natural. If we didn't have a certain amount of carbon dioxide and methane and water vapor in our atmosphere, the Earth would be at least 30 degrees colder, and we wouldn't be here having this conversation. But more recently, human activity has enhanced the concentration of methane and carbon dioxide. And then water vapor actually follows the warming of the planet. If the planet is warmer, remember 70% of the Earth is covered by water. If we heat the planet, which is what we have done, we will have more evaporation and more water vapor. So the point I want to make here is that changes in the climate system are driven by both natural and anthropogenic factors. The next point is, that would be the fourth one down, is that global climate change involves many changes. It's not just all about temperature, although temperature is often what we talk about most. We're having right now changes in precipitation. We're having an increase in extreme weather events. We know that sea level is rising. Glaciers around the world are melting. Ecosystems are changing, and many of these changes actually now affect public health. Climate change is very much linked to public health. The report that came out, and Fran mentioned that, which is the third National Climate Assessment for the Midwest, one of the key points here is that increased heat wave intensity and frequency, increased humidity, degraded air quality, reduced water quality will all increase public health risks. So there are many, many aspects to global climate change and not just temperature. Going to the fifth point, human activities that release carbon dioxide and other greenhouse gases such as methane, as well as aerosols, and those would be particles, that release these to the atmosphere, are now the dominant cause of the warming of our planet. And that's essentially since the middle of the 20th century. And this, I'll show you a slide when I get to the slides, that essentially shows you the science that underpins that statement. But all of the major scientific societies agree with this statement. And the Intergovernmental Panel on Climate Change just released its fifth assessment. It started releasing assessments in 1990. And the two take-home messages from the IPCC were that, number one, the fact that the Earth is warming is unequivocal. It's not up for debate. Number two is that most of the warming that we've observed since 1950 is due to the increased emissions of these greenhouse gases. And then the next bullet point indicates that, just says that recent scientific assessments highlight the role of human activities. And the three main the three of those, one has been mentioned, the National Climate Assessment, the other one's been mentioned, the Intergovernmental Panel on Climate Change, and then recently the National Academy of Sciences, along with the British Royal Society, released a report entitled Climate Change, Evidence and Causes. And it's highlighted on the sheet that's available for you as you leave. The next point I want to make is that the world is challenged by the growing need for energy. No one wants to turn the clock back. No one wants to live with less energy. But as one of our, as was said earlier about the fact that we have 7.3 billion people on the planet, it's important to remember that about 1.5 billion of those people do not have access to electricity. And you can think back when the derecho came through and, many of us didn't have power for multiple days, how horrible it is to live without energy and how dependent we are on it. What we really aspire to have for our world is we want people to be prosperous. And prosperity does require energy. But the challenge is how to meet the energy need that we have, and talk about what are some of our options for doing that. We need new ways to provide energy. We cannot continue to provide energy in the ways that we have done over the last 150 years. And much of the things that we have built that are actually now appear to be unsustainable going forward were built on cheap energy. Energy has been cheap. And now the problem we have is the 1.5 billion people who are going to need energy. You know, the Chinese society aspires to the middle class. All of this means eating more meat, moving up on the food chain, increasing the demand on the systems that sustain everything on the planet. And have my honors students do a little calculation, and that is, we just look at the energy demand from the U.S. Society, and we look at our population. You know, we're just a little bit over 300 million people, third most populous nation in the world. And the question is, what if every person on the planet consumed energy, and it's not just energy, it's all the things that we eat that energy is required, the production of our food, the transportation of our food, the fiber that makes our clothes, you know, everything that we have requires resources. And the answer is, it's almost 4 planets. To provide everything that America enjoys for 7.3 billion people, we need almost 4 planets. Obviously, the path we're on is not sustainable. And then the last bullet point is how we choose to power our planet going forward, and how rapidly we make the necessary changes is really going to determine our collective future. And it truly is a collective future. Everything on the earth is dependent upon everything else. It's just a series of interconnected systems, many of which are inanimate, but the human part of the system is equally connected to those inanimate systems. So with that, what I'd like to do is just go through some slides that kind of highlight those key points. And I'd like to say for those listening online or on the radio that these slides will be posted on the Akron Roundtable website. So the first is just to look at the evidence. Here we have essentially the global land-ocean temperatures. They're shown as departures. And essentially the record starts around 1880 and comes up to 2014. And essentially, it's not, the Earth is warming, but environmental conditions are changing, and we've talked about that. Now, the last year was considered the warmest year on record. Statistically, it's indistinguishable from 2010 and from 2005, the 3 warmest years on record. And since the turn of the last century, since 1900, the globally average temperature of our planet has warmed by about 1 degree centigrade. But when we talk about, I don't use the word global warming because it implies that it's warming everywhere on the planet. It's much better to talk about global climate change. But here you can see the distribution of the warming and cooling of temperatures since 1900 to 2014. You can see, I'll try to use the mouse to highlight. So you can see that in the high Arctic, we have quite a bit of warming. And here in the North Atlantic, we actually have an area that has been cooling over the last century. So again, overall, the Earth is warming, and this information comes from NASA. I want to just discuss the important difference between weather and climate. Often I will hear people say, well, how can you make predictions about what the climate will be like in 2020, 2050, or 2100? Do that, of course, using climate models, when we can't even predict what the weather is going to be next week. And so the thing is, there's a confusion about the difference between climate and weather. Climate is essentially the longer-term changes. And from a climatological point of view, we talk about the climate average, which is a 30-year average. So I use the dog walker and the dog. You can see the man here, and he's walking the dog. The dog is on the leash, right? So the man knows where he's going. He's probably left his house and he's going to the newspaper stand to get a newspaper or maybe a coffee, and he's walking his dog. You see the dog is jumping around. He's going up here to sniff a fire hydrant. He's going down here. He's maybe looking at a McDonald's wrapper or something through it. The dog is just moving quickly. Well, you can think of this as the dog walker is really the climate. The trajectory of the dog walker is fairly straightforward and much easier to predict. What the dog is going to be doing anytime along the walk is anybody's guess. And so you have to think about the dog as the weather. All right? So you've got to make the distinction between climate and weather. Now, it was said, and I don't know if it's true, that Mark Twain said, climate is what you expect, but weather is what you get. So I looked up some statistics. So for Akron, in February, the 30-year average temperature is 29.4 degrees Fahrenheit. But for February 2015, just last month, the average was 16 Fahrenheit. It was, 13 and a half degrees colder. And people, of course, you don't want to go out and give a talk about global climate change when you've got 2 feet of snow and the temperature's 13 degrees below the norm. But we're human beings and we don't have long memories, to be honest. And so just to take a look, our perception from the Akron or the Columbus point of view is, wow, February was really cold. NASA or NOAA just released the statistics. February 2015 was the second warmest February on record since record keeping began. The important point is we have to look at climate from a larger perspective, spatially, and from a longer term perspective. We cannot look at what's happening outside our door. That is not climate, that's weather. Now, I had mentioned that there are many changes going on, and I mentioned the fact that glaciers are melting. Lonnie and I have devoted our careers to studying glaciers, so I thought I would just show you 3 examples. This is the margin of the Quelccaya ice cap in the southern Andes of Peru in 1977. We've been studying this glacier since 1974. Here is the same margin taken in 2002. We go back to this glacier at least once every 3 years. This is the largest outlet glacier from the Quelccaya, taken in 1978, and the next one will show you the retreat of that outlet glacier and the photo of 2011. And that lake now covers about 60 acres and is over 200 feet deep. And then the last I'll show you is this glacier in New Guinea. Yes, in New Guinea they have glaciers, and our team drilled 3 ice cores from this glacier, 2 up on this dome and 1 over, my mouse isn't working that well, 1 on this dome. And the next slide I'm going to show you is just 4 years later in 2014. This glacier will probably be gone by the end of this decade. All right. Now I want to come to carbon dioxide because that is one of the most important greenhouse gases, second only to water vapor. And these are the measurements from Mauna Loa, taken in they were started in 1957. You can see how that's increased. But what we don't see here is what happened prior to the 1950s. But to get that record, we can actually use ice cores, and I'm going to show you the results from the oldest ice core ever drilled. It's from the East Antarctic ice sheet. And here in red are the temperatures. This is an 800,000 year record. I'm sorry the mouse isn't working very well. But here is today, and 800,000 years then would be to your left. And on top is the concentration of carbon dioxide, and that gas is measured from the air that is extracted from the bubbles that are contained within the ice. And you see those 8 glacial interglacial cycles. This is the expansion you mentioned, the fact that glaciers come and glaciers go, ice sheets expand, ice sheets contract. Columbus, 20,000 years ago, was under an ice sheet a mile high. At that time, carbon dioxide concentration on the planet was low. The ice was in, or the planet was in what was called a popular word, an ice age. So what happens if we could use this as the backdrop? All of this is natural variability. Humans have no impact on what we're seeing here in terms of either temperature or carbon dioxide. But that's where we are today. The carbon dioxide's at 400 parts per million. You can see we have never seen a CO2 as high as it is today, and actually that's for the last 2.3 million years, not just the 800,000 I'm showing you. And then if we look at the projections from the Intergovernmental Panel on Climate Change as to where CO2 concentrations are likely to be in 2100, which actually is only 96 years from now. It sounds a long way off, it's not. You can see how high the concentrations might go. And one of the problems with CO2 is that it's a long-lived gas. It stays in the atmosphere decades to centuries. And this shows the decay curve for fossil fuel CO2 emissions. Essentially, 33% of the CO2 emitted today will be in the atmosphere 100 years from now, and 20% of the CO2 emitted today will be in the atmosphere 1,000 years from now. This is a long-term issue, and what we do today is important, but what we do next year, next decade, and throughout this century is very important for the centuries to come. Now, I mentioned the fact that we had both natural and anthropogenic factors. This graph shows the projections for temperature on the planet from 1900 to 2000. The solid line you see is the temperature curve I've already shown you. This is the known. We know what the temperature history of the planet has been. We've lived through it, we've measured it. But what we want to know is how well can our models hindcast or forecast backward the temperatures that we know. And if you look, you will see the kind of the green scenario. That's if we force the models only with natural factors, and I mentioned those earlier, you notice after 1960, the models can't get the right answer. The models are staying fairly flat. You'll see a big dip right around 1990. That's the eruption of Mount Pinatubo that I mentioned. But if you look at the blue band, that is the projections if we add in human activity, the human forcing functions. So it takes both the natural and the human factors to essentially have the models perform correctly and predict backward what we already know has transpired. So, just my last few slides. So what actions might give us the best possible scenario for the future? We can debate any of these and all of them, and they are hotly debated and contested. One is possibly put a price on carbon, and you can do that by a tax or a cap. Economists look at this, and there are positive and negative attributes to both. We can use our efficiency standards. Some of us say that the cheapest, easiest way to get more energy right now is to use the energy that we already produce and use it more wisely, make every joule do more work. And we can also give incentives, and we can use restrictions on harmful practices. We can fund research and development of new technologies and speed the transition. China has invested $90 billion in renewable energies plus nuclear. And they are making those investments. They have to because their environment is terrible. We can prepare to adapt. We call this anticipatory adaptation. It's cheapest. Think ahead, what might the damage be and what can I do to reduce the damage? I like the little statement, it's cheaper to prepare than to repair. So trying to take action, and especially for expensive infrastructure. If you build a power plant, you're going to run that power plant for 40 or 50 years. Or a nuclear facility, you're going to run it for 40 or 50 years. So you want to make sure that you protect your investment. Geoengineering is now talked about quite a bit. The National Academy of Sciences just released 2 reports talking about geoengineering. This is human modification of the climate system. It would be, number one, a last-ditch effort. It's definitely not something that we want to engage in a non-thoughtful way. What we need to do is proceed with caution. That was really the take-home from the Academy. And then be prepared to adjust your plan. Make your plan, but remember, the climate landscape changes and the human landscape changes, so you constantly have to revisit your plans, revise them, and amend the plan. So just to sum up, how the world chooses to supply the power that it will need will be determined in large measure, or it's going to determine in large measure Earth's climate future. How we power the Earth will determine our climate future. This is a global problem, and it's going to require global scale solutions. The options are mitigation, that's essentially reducing emissions. There's adaptation, that is making modifications so that you can quote unquote live with what you can't mitigate. And then finally, another outcome is possible suffering. It's not disputed that ultimately every human on the planet will be touched in some way by climate change. And those touched most greatly will be those in third world countries that have contributed less to the problem but don't have the resources to mitigate or adapt. And then the greatest challenges that we'll have for the 21st century will be learning how to get along with each other. We see how critical that is in our world today. And the second is learning to get along with our planet. And these 2 challenges deal with human behavior, and they're closely related. So a lot of our future depends upon us and the decisions we make. Earth is a wonderful place. It's unique in the universe, at least as what we know of the universe now. We know climate is changing, and for global climate change, nature is the timekeeper, and unfortunately, we don't see the clock. So those are my comments.
Our speaker has graciously agreed to answer written questions from the audience. This is a hallmark of the Akron Roundtable event. Our audience always has very rich questions. I know we have only a little bit of time, so please write your questions on note cards. They'll be collected by a member of the Akron Roundtable staff and presented by John Petruris, a member of our board, and also the Finance Committee of the Akron Roundtable.
Ellen, I'll take credit for this one after having visited your website. I know you talked a little bit about these ice core samples. What do ice core samples actually tell us? And what are some of the more profound revelations that you've ever found in your studies of them?
Essentially, ice cores are just cylinders of ice that we take. We have drills. We drill through these ice masses. And if you think of it as a layer cake, remember the photo I showed of the Kilkaya ice cap, and you saw those annual layers. You drill through them, and you get every year. And so what we analyze are the chemical and the physical properties, the chemical constituents, and then the physical properties of the ice. There are many, many things that we eat until the ice melts. And so we use specific isotopes to tell us about temperature. We look at salt. We actually measure sulfate, and that tells us about, we can see the burning of coal in North America, the sulfate aerosols when burning of coal began, We actually get sulfate aerosols falling out over the Greenland ice sheet. We actually find insects, we find plants, we find plant pollen. So we can construct something about the vegetation in the area around the ice fields. Not so much for Antarctica, but for these tropical glaciers where we have vegetation. And I would have to come back and say the greatest contribution that ice cores have made today would actually be that carbon dioxide record, that 800,000 year record of CO2 of the atmosphere, because there is nowhere else that you can go to get an 800,000-year-old parcel of ancient air. So I would say that's the most unique and important.
Here's another. Are all the consequences of global climate change negative?
Absolutely not. They are not all negative. And let me just give you an example. I didn't tell him to ask me this, but from the U.S. Third National Climate Assessment, in terms of their key messages, they start out saying that longer growing seasons, which we're going to have, and the elevated carbon dioxide levels will increase yields of some crops. All right? It says, though those benefits will be progressively offset by extreme weather events. Though adaptation options can reduce some of the detrimental effects, in the long term, the combined stresses associated with climate change are expected to decrease agricultural productivity. Certainly, if you live in Greenland, if you're Greenlandic, right now, actually the shrinking of the glaciers, the fact that there's less ice around Greenland, and it's warming, they actually are engaging in more agriculture. The sea ice, the permanent sea ice that covers the Arctic Ocean is now diminishing every summer. And there will be some positives there in that we're going to see a lot of competition for resources, minerals, other like fossil fuels will be extracted. And if the sea ice in the Arctic is diminished, it's going to take a lot less time to go from Europe across the top of the pole to Asia. Ships are going to get there a lot faster, so that's going to be a benefit to the shipping industry.
There are many questions that we're not going to be able to get to everyone, but what is Ohio doing to create jobs in alternative energy sources?
I'm probably not the best person to answer that.
Better than me.
Well, I feel empowered then. I really can't address that, but I do know, for example, in Columbus, there's a big push. Our mayor, Mayor Coleman, has had a push for green energy. I don't know, you know more than I do since you're in the energy business, but I know that, for example, in Ohio, we're a top producer of infrastructure for wind energy. But my understanding is that after the manufacturing of those parts, essentially most of them are going to Germany. But I think our potential is great. We are an agricultural and a manufacturing state. We have histories in that. And I think that, ideally we should jump into the manufacturing side. I mean, one of the challenges right now is batteries. Solar and wind we need better batteries. So that might be a place where we could do more. But I can't give more. I'm not a business person.
And perhaps one final one, and this was going to come. How can we best respond to those who do not accept the evidence for climate change, particularly politicians? All
right, that is a real challenge because we know that it really is in the political arenas it's really where the rubber hits the road and the truly important decisions as to how we're going to go forward are made. To be frank, there are some people who, no matter what you put in front of them, you are not going to change their minds. And some people operate strictly from a belief system. Their decisions they make are impacted by their values. They're impacted by the people they associate with, the people whose information they value. I teach an honors course, and I started the course every semester with a questionnaire asking my students, where do you get your information? Most of them get their information on the internet now, and they get it from their friends and their family. That's hard to compete with that. In our class, what I point out to them is, again, we have to look at the data. You remember one of the first slides I showed you that had the temperature history for the planet based upon thousands and thousands of observations. I get asked all the time, and people are well-meaning, do you believe in global warming? And my response is, it is not a belief system. You don't believe in science. You do science. You apply the scientific method. You collect data. You look at what the data tell you. You test it and test it and test it. And if it stands the test of time, then it, of course, becomes more factual. And so I try to send people to, that's why I carry around, let's say, this sheet that you can pick up over there. Because this information comes from the peer-reviewed literature, from the major organizations that promote science in our country, and NASA, NOAA, the Intergovernmental Panel on Climate Change. It's really where we need to go for the information. I mean, I did see on the news Senator Inhofe throwing a snowball in the Senate chambers to point out that there's no global warming because there was tons of snow in Washington. My daughter works in the federal government, and they were shut down, for a while because, because of all the snow. That's all grandstanding. The unfortunate part is that people don't really question as deeply as they should. And it's a big challenge for us in the scientific community. I was just talking with someone, if anybody has, has seen the recent National Geographic where the cover, Science is Under Attack. As a climate scientist, all of us are constantly under attack, but it is not just climate science. I mean, evolution is under attack. Many aspects of science right now are under attack. And exactly where it's coming from, except out of either A, ignorance, or B, people who really just don't want to accept inconvenient information because it means you have to do something. I'm not really sure. But, humans don't like change. I'm just like you. None of us want change. We're in our groove, we're comfortable, and some of the things that we see and the questions that are asked, if answered honestly, will require that we make big changes in the future.
Well, speaking of being in the groove, I hope the Ohio State football team continues to stay in their groove and bring home another college championship. Ellen, thank you for being with us today. On behalf of the Akron Roundtable, it's my pleasure to present you with a contemplative sun as a memento of your visit with us this afternoon. This celebratory work of art was designed exclusively for the Akron Roundtable by Akron artist and craftsman Don Drum. Thank you very much for being with us. We invite the audience to join us at the Quaker Station in downtown Akron on Thursday, April 16th, when the Akron Roundtable will host a diverse group of panelists in a discussion which follows up on the Akron Beacon Journal series, Who Will Lead? The title for this panel is aptly named #AkronLeader, Building the Conversation. Thank you for being with us today, and we look forward to seeing you next month.